All right, on to the second page, number 10. Find the following information and sketch a graph, at least 2 points, of the equation y equals 2 to the x minus 1 plus 3. Consider the parent function, key points, and then transformations. So to start, we have an exponential with a base 2. Well, all exponentials are going to go through the point 0, 1, 1 comma base, which our base is 2, and have a horizontal asymptote at y equals 0. So I'm going to start with the parent function. Y equals 0, the point 1, 2, the point 0, 1. Here is my parent. Well, based on this parent, I'm going to shift negative 1 inside the function, which means I'm going to go to the right 1. If I shift my horizontal line over to the right, it stays right where it is. So there's my right 1 transformation. Then this plus 3 is going to take the whole thing and shift up 3. Horizontal line gets shifted up 3. And so my final graph is this one in green. Okay, so that's one way to go. You also could graph on your calculator and read stuff from there if you feel you are calculator savvy. That's totally fine, but it said to, consider transformations. So now let's analyze this green graph, which again, you could have gotten by going to, I'll even make it green for us, 2 to the x minus 1 plus 3. Zoom 6. There we go. Same graph I'm looking at right now. So our domain for any exponential function is going to be negative infinity to infinity. Our range is our low point, which was the asymptote that we're going to approach. I'm going to approach 3 but never get there, and then continue to grow positively. My asymptote is at the line y equals 3, because everywhere that y equals 3, I'm not going to touch. And then intercepts. Well, you can use your calculator, but let's also talk about intercepts and how we find them in math. An x-intercept is where y is equal to 0. A y-intercept is going to be where x is equal to 0. Well, thinking smarter, not harder, this is supposed to be where I cross the x-axis. Look at your graph in green. Will you ever cross the x-axis? No. You won't, so there are no x-intercepts. Looking at your graph, 0, comma, if I go in 0, out comes, that's a number I can't really quite tell. Good thing I have my equation that I can sub in 0 for my x value. So this will become 2 to the negative first plus 3. 2 to the negative first is the same thing as 1/2 plus 3, which means I get a y-intercept of 0, comma, 3.5 or 7 halves, right? So you could write it as 3.5 if you would like to. If you are a calculator person, you could go to your table and you could notice, let me change my table settings. I'm going to start at 0, counting by 1. You'll notice that there's your y-intercept, 0, 3.5, and it doesn't matter how far you go, you're never going to get to, well, it says you get to 3, but that's just because your calculator can't do that many decimals, right? 3.00001. But you will never get to 0. So we don't have any x-intercepts. If you wanted to find your x-intercepts by hand, you would say, okay, where does my whole function equal 0? And so you'd say negative 3 equals 2 to the x minus 1. And then you have to take a log base 2 of negative 3. But this can never happen because the domain of a logarithm is all positive numbers. All right, graph the function g of x. This time we have a logarithmic function with a base of 4. All logarithmic functions go through the point 1, 0, base, comma, 1, and they have a vertical asymptote at x equals 0. So my parent function, 1, 0, 4, 1, and remember it doesn't look like a square root graph. It does go all the way down to negative infinity. It doesn't stop just because your calculator says that it stops. This one I'm going to move to the left 2 and down 2. I'm going to do it all together. So I'm going to go take this vertical asymptote, move it to the left 2, and then shift it down 2. Well, when you shift a vertical line up or down, it doesn't actually change its location. This point, I'm going to move to the left 2, down 2, left 2, down 2, And this green function ends up being my graph that I'm analyzing. Then, if you are a calculator person, that's totally fine. If you have the fancy change of base, you can use that. If you don't, you can rewrite it using your change of base, but that's kind of a lot of work. This is log base 4, x plus 2 minus 2. There's my graph. And again, be smarter than your calculator. Your calculator just ran out of pixels. It can't show you that this goes all the way down to negative infinity. All right, domain of a logarithmic graph is based off of that vertical asymptote in the same way that the range for the exponential was based on your horizontal asymptote. So in this case, I can have as close to negative 2 as I want to be without touching it, all the way to infinity. My range is all real numbers. My asymptote was at x equals negative 2. Intercepts. Well, looking at this, I definitely cross the y-axis, and I definitely will cross the x-axis at some point. So again, to find an x-intercept, you set y to 0. To find a y-intercept, you set x to 0. I'm going to do the x-intercept first. So 0 equals log base 4 of x plus 2 minus 2. I'm going to add 2 to the other side. I'm going to undo my logarithm by raising each side with a base of 4. Cancel out. 16 is equal to x plus 2. 14 is equal to x. So I have an x-intercept at 14, comma 0. If I want to find my y-intercept, I'm going to plug in 0 for my x value. So I end up with y equals log base 4 of 2 minus 2. You could just leave this if you wanted to. If you put this in your calculator, you're saying 4 to what power gives you 2. That's going to be a 1/2 power, 1/2 minus 2. Again, it's all in your calculator if you want it to be. We end up with negative 3/2. So let me show you what I mean by your calculator. You can go to your table, and you can figure out when x equals 0, y is equal to negative 1.5. You also then are looking for where does the y value equal 0. That's going to be when x is 14. So you can use your table. You also could type in your log base. Oh, no. Come on. Log base 4 of x plus 2. Not x plus 2, 0 plus 2. Come on, Schwartz. 0 plus 2. You never want to type x in your home screen because your calculator might have stuff stored weird, so be mindful of that. Negative 1.5. All right. Following formulas will be needed for your test. We will provide them for you, but you do need to know how to use them. Okay? So again, this review so far is very heavy in Unit 10. If there's anything so far you're struggling with, go back and look at your Unit 10 notes. $2,750 is invested at a rate of 6% compounded quarterly. What is the balance at the end of 7 years? Well, this is only if I'm compounding continuously. This is used for all other compounds. Since I'm going quarterly, I'm going to use this one. What is the balance at the end of 7 years? And how much more money would you earn if your interest in this account were compounded continuously? So I want to know my amount after 7 years. I had a principal of $2,750. 1 plus, that all stays. My interest rate was 6%. Compounding quarterly means 4 times. It's my number of compounds per year. And I'm checking what's happening at the end of 7 years. Well, luckily for me, this is one that I can just type into my calculator. You want to just go with your order of operations. So I'm going to do 1 plus 0.06 divided by 4. Then I'm going to raise that to the 28th power. And then I'm going to multiply that by 2,750. So $4,172.36 is my amount after 7 years, compounded quarterly. $4,172.36. 0.36. The next question says, how much more money would you earn if you compounded continuously? Well, here's my compounding continuously. A is still what I'm looking for. I need to figure out how much I have after continuous compounding. P is still 2750. E is just E, that's part of the formula. And this time my rate goes up in the exponent and my time is still after 7 years. So in my calculator, I'm going to go second E raised to the 0.06 times 7. If you have the older calculator, make sure that you have the times 7 in your exponent. And multiply that by 2750. I get 4185.39. 4185.39. The question didn't ask how much do you make continuously. It asked how much more would you earn continuously. So we're going to take this continuous minus this quarterly, and we end up with a difference of $13.03 is how much more you would make if we compounded continuously versus quarterly. All right, I'm going to stop there for this video. We'll pick up with number 13 in the next.